Hello, this is Kenneth Wong, contributing editor for Desktop Engineering magazine. So last week, Dassault Systems released a new version of its simulation and analysis software, part of its Simulia portfolio. This is a high-end product available as a CATIA add-on module or as an independent package. I'm going to give you a brief look at Abaqus 6.10, compiled from excerpts from the demonstration of the software that I just saw. What we're doing here is isolating the front cover of the camera from the camera assembly to first create a mixed surface part we can use for analysis. It's fairly straightforward. You identify the side from which to offset, define the distance of the offset, then identify the opposite side, then create the part. One of the new features of this release is the view cut function. It's a way to let you see through your mixed surface parts and analysis results in a cross-sectional view. View cut works not just on parts, but also on assemblies too. So here, for instance, is view cut of the landing gear and the wheel section. Based on the type of analysis you're doing, the software lets you pick the meshing options from stress test, acoustic, continuum, and so on. Let's have a look at some of the surface healing and mesh repair tools. Take, for instance, this model of an airplane fuselage. We'll try to extend the surfaces along this section, a simulation of what a manufacturer might do to analyze a longer mid-section. So here, we'll select the edge of these meshes, then ask the software to project them to the next edge. This dialog box here controls the meshing behavior by defining the mesh bias either by size or by number. There are also, of course, options to renumber the nodes in your mesh plane along a certain edge, or apply a global renumbering scheme to all your nodes. Let's have a look at another example. This one not just about refining the existing meshes or adjusting them, but about creating a whole new subsection of geometry. Here, what we have are three airflow paths, but one is missing. So we can create the outer paths geometry by creating a sweep along the anticipated flow path. So we are almost ready for analysis. Let's go ahead and define the boundary conditions, that is, to set up our scenario. So we'll select or define the load, the method of analysis, the type of analysis, pick the type of solver and equations to deploy, specify turbulence models if you want any, define fluid density, define entry points of the fluids, then exit points, and tell the software what the fluid temperature is, then set up your job. All that is left now is to run the scenario. Some of these surface repair works and mesh repair works and supplementary 3D modeling works that you've seen done here, they could also be done in the original computer-aided design package, of course, whether it's CATIA or SolidWorks or something else altogether. But it's worth considering that often the experts running analysis may not even own a seat of that CAD program, or may not even be familiar enough with the program to know how to use it. So it's helpful to have these tools that they can use to repair the analysis models and meshes right there in the analysis program. Now here are the results, shown with a view cut to let you take a peek at how temperature distribution and flow look like from inside the flow paths. So until next time, this is Kenneth Wong, contributing editor for Desktop Engineering Magazine, leaving you with an encore performance of Abaqus 6.10.